Energy drinks may look simple. A slim aluminum can filled with a sweet carbonated liquid. But behind every can of an energy drink like Red Bull is a tightly controlled industrial process built around chemistry, precision dosing, sanitation, and high-speed packaging. Each can must contain exact amounts of caffeine, taurine, vitamins, sugar, and flavor compounds, all dissolved perfectly and sealed under pressure to ensure stability and safety. What begins as purified water and powdered ingredients is transformed through mixing, carbonation, pasteurization, and canning into a shelf-stable beverage designed to taste identical anywhere in the world. And today on the How Factory, we're stepping inside modern beverage plants to see exactly how an energy drink like Red Bull is made, from ingredients to sealed can. The rise of energy drinks is a relatively recent chapter in food manufacturing history. While caffeinated beverages have existed for centuries in the form of coffee and tea, the modern energy drink emerged in the late 20th century. The concept was to deliver caffeine in a ready-to-drink format, enhanced with functional ingredients and a distinctive flavor profile. As demand exploded globally, production shifted from small regional batches to massive centralized facilities capable of producing millions of cans per day. Consistency became non-negotiable. Every can had to deliver the same taste, carbonation level, and physiological effect. The process begins with water, which makes up the vast majority of the final product. Water quality is critical. Beverage plants use multi-stage purification systems to ensure absolute consistency. Incoming municipal or well water is first filtered to remove particles and sediments. It then passes through carbon filtration to remove chlorine, odors, and organic compounds. Many facilities also use reverse osmosis systems to strip dissolved minerals, producing nearly pure water. This allows manufacturers to rebuild the water profile precisely for flavor and stability. Once purified, the water is stored in large stainless steel tanks under sanitary conditions. From here, it is pumped into mixing systems where ingredients are added. These ingredients include caffeine, taurine, sugars, or sweeteners, acids, vitamins, flavorings, and colorants. Each ingredient plays a specific role and must be measured with extreme precision. Caffeine is one of the most critical components. In energy drink production, caffeine is typically added in powdered or liquid form derived from synthetic sources or plant extracts. The dosage must be exact, as caffeine content is regulated and directly affects both safety and product labeling. Automated dosing systems weigh and dispense caffeine to the gram, ensuring every batch meets specification. Taurine is another defining ingredient. Taurine is an amino acid naturally found in the human body and is added for its functional associations. Like caffeine, taurine is added in powdered form and dissolved completely into the water. Because taurine has a distinct taste, its concentration must be carefully balanced with other ingredients to maintain the signature flavor. Sugars provide sweetness and body. Traditional energy drinks use sucrose and glucose, while sugar-free versions rely on high-intensity sweeteners. Sugar is dissolved in heated mixing tanks to ensure full solubility. Temperature control is important here. Heating speeds dissolution but must be carefully managed to prevent degradation or unwanted flavor changes. Acids such as citric acid are added next. Acids serve multiple purposes. They balance sweetness, enhance flavor brightness, and lower pH to improve microbial stability. The pH of the beverage is a critical control point. Too high and the drink becomes vulnerable to spoilage. Too low and it tastes overly sharp. Sensors continuously monitor acidity to keep it within tight limits. Vitamins, particularly B vitamins, are added in very small quantities. These micronutrients are sensitive to heat and light, so they are introduced at specific stages to minimize degradation. Automated microdosing systems ensure accuracy, as even small deviations can affect nutritional labeling compliance. Flavorings are added last in the mixing stage. These proprietary blends define the characteristic taste of the energy drink. Flavor compounds are highly concentrated and are typically added as liquid emulsions. Mixing systems ensure uniform distribution throughout the batch, preventing stratification or flavor variation. Once all ingredients are added, the mixture is thoroughly blended. High shear mixers and circulation pumps ensure complete dissolution and homogeneity. The result is a flat, non-carbonated liquid known as the base beverage. At this stage, it resembles a flavored syrup diluted with water. Before carbonation, the beverage undergoes filtration. Fine filters remove any undissolved particles or impurities. This step is essential for clarity, mouthfeel, and equipment protection downstream. The filtered beverage is then cooled to near freezing temperatures. Cold liquid absorbs carbon dioxide more efficiently, which is critical for consistent carbonation. Carbonation is introduced under controlled pressure. Carbon dioxide gas is injected into the chilled beverage using carbonation systems that regulate pressure and flow precisely. The level of carbonation affects mouthfeel, flavor perception, and can integrity. Too much carbonation can cause foaming during filling. Too little results in a flat product. Sensors measure dissolved CO2 continuously to maintain consistency. Once carbonated, the beverage must be protected from contamination. From this point forward, the system is fully enclosed and pressurized. Stainless steel pipes transport the drink directly to filling lines. Air exposure is minimized to prevent oxygen pickup, which can degrade flavor and reduce shelf life. Before filling, the beverage often undergoes pasteurization or microbial stabilization. Some energy drinks are pasteurized using flash heat treatment, where the liquid is heated briefly and then rapidly cooled. This kills microorganisms without significantly affecting flavor or vitamins. Other systems rely on sterile filtration and low pH for stability. The choice depends on formulation and regulatory requirements. Meanwhile, aluminum cans are prepared. Empty cans arrive at the facility in bulk and are stored in clean environments. Before filling, cans pass through rinsing systems that remove dust or debris using filtered air or sterile water. Cleanliness is critical, as even microscopic contamination can compromise product safety. Filling lines operate at remarkable speed. Modern canning machines can fill and seal tens of thousands of cans per hour. The carbonated beverage is dispensed into each can under pressure to prevent CO2 loss. Fill levels are monitored continuously using sensors to ensure accuracy. Overfilled cans waste product. Underfilled cans violate labeling regulations. Immediately after filling, lids are placed on the cans and sealed using seaming machines. The seam must be perfectly formed to prevent leaks and maintain internal pressure. Seaming rollers fold the lid and can rim together in a precise sequence. Automated systems inspect seams using cameras and pressure tests to verify integrity. After sealing, cans may pass through a tunnel pasteurizer if required. In this system, sealed cans are sprayed with warm water to gently heat the contents, then gradually cooled. This provides additional microbial safety while minimizing thermal stress on the product and packaging. Once stabilized, cans move to inspection. Vision systems check for fill level, seam quality, dents, and labeling accuracy. Random samples are removed for laboratory testing. These tests measure caffeine concentration, carbonation level, pH, sweetness, and flavor consistency. Sensory panels may also evaluate taste and aroma. Approved cans proceed to packaging. Cans are grouped into multi-packs using plastic rings, cardboard sleeves, or shrink wrap. Packaging machines operate at high speed, forming and sealing packages automatically. Date codes and batch numbers are printed for traceability, allowing every can to be traced back to its production run. Packaged cans are boxed and palletized using robotic systems. Pallets are wrapped for stability and labeled for distribution. From here, the product enters the logistics network, traveling to warehouses, retailers, and vending machines around the world. Behind the visible production line lies extensive sanitation and quality control infrastructure. Beverage plants operate under strict hygiene standards. Equipment is cleaned using clean-in-place systems that circulate detergents and sanitizers through pipes and tanks without disassembly. These cleaning cycles are validated to ensure all residues are removed. Water usage, ingredient handling, and waste management are carefully monitored. Sustainability is increasingly important in energy drink production. Many facilities recover CO2 from other industrial processes, reduce water consumption through recycling systems, and use lightweight cans to minimize material use. Aluminum itself is highly recyclable, contributing to lower environmental impact. What makes energy drink manufacturing remarkable is the level of precision required at high speed. Ingredients measured in milligrams must be evenly distributed across thousands of liters. Carbonation must remain stable from filling to consumption. Every can must meet regulatory standards while tasting exactly the same as every other can produced. From water purification and ingredient dosing, to carbonation, pasteurization, can seaming, and high-speed packaging, the production of an energy drink like Red Bull is a tightly coordinated system built for consistency and safety at global scale. And that is how an energy drink like Red Bull is made: mixed, carbonated, stabilized, sealed, and packaged, transforming purified water and functional ingredients into a pressurized can designed to deliver the same energy and flavor every time. Thanks for watching The How Factory.